Welcome friends to the class of marketing research and analysis. We will continue from the last lecture where we were discussing about a special case of entering the data during a multiple regression case, right. So, we learnt about the effect of the order of entry of a data in case of a stepwise regression, and I also explained about forward regression and backward regression, right. But then we realized that stepwise regression has its own problems, that sometimes a very important variable might become unimportant and may be removed from the study, which resulting in a overall weakness, creating an overall weakness for the equation or the regressions, the research study, right. So, to avoid that problem, I said that we can use a new approach which is called the hierarchical regression, right. So, hierarchical regression technique is a technique which is basically used to enter the data into the regression equation in a blockwise manner, so that this block manner is used on basis of, is developed on basis of some theory or some logic, right. So, not that means the computer does not do it for you, rather it is based on certain logic created by the researcher from which is from some past studies or something, right. And today I will also explain you about a special case of regression called the dummy variable regression, which is highly useful for researchers around who are doing some or the other way of research, right. So, continuing with the hierarchical multiple regression process. So, the IVs, independent variables or the predictors, are entered in the steps or blocks, okay. So, maybe the first block maybe has got 2 variables x1 x2, the second variable block has got x3 x4, or it could be like the first block has got only x1, second block has got x2 x3 x4, or the first block has got x1 x2 x3 and the second block has got only x4. Now, how this block is made completely depends on the knowledge of the researcher, right. So, on the basis of theory he has to do it, he or she has to do it. Each IV is assessed in terms of what it adds to the prediction of the dependent variable after the previous IVs have been controlled for. So, when you are using this, so automatically you are controlling the other variables, right. So, the overall model and the relative contribution of each block is assessed. So, we will see that how. Now, how do you measure this contribution? This contribution is measured through the R square. I had explained also in the last lecture about the concept of R square and the difference between R square and adjusted R square, okay. Some of the assumptions is normal like any multiple regression, that it should be linear, normal. So, the homogeneity of variance, multicollinearity should not be there and outlier should be absent, okay. Now, let us take this case. A country's rate of female literacy, because a country like India, for example, Bangladesh, India, some of the Asian economies, the female literacy rate is very low or very poor, right. So, we are saying that it is associated with the smaller rate of annual population increase, right, and a greater gross domestic product and a high per capita income. So, I am saying what I am thinking is, so because this will improve if the annual population growth is increasing or decreasing, accordingly it will have an effect on the literacy rate. The GDP, if it increases, and the per capita income also if it is increases, that also will have an impact on the Y, that is my female literacy, right. So, these 3 variables we have taken, independent variables, predictors and one dependent variable. So, there are 4 variables, okay. So, in the block 1 what I have done is, I felt that smaller rate of annual population increase x1 is separate from these 2, and these 2, a greater gross domestic product x2 and a higher per capita income, both are related to the financial parameters, can be considered as 1, right. So, this is block 1 I have taken, and this is I have taken as block 2, right, and I want to see whether my logic comes true or not. So, when I can I create a model which is more appropriate and more powerful and which explains my regression in a better way, right. So, to do that, so how do you do? So, these are something for you, you can use it later on also. So, just to show, go to analyze regression linear and move the dependent variable y into the dependent box. Now, move x1 first into the independent box, click next. So, let me show you, and then move second x2 and x3 into the independent box. Now, let me go to the data set. So, this is the data set which I have brought. So, x1, x2, x3 and y, right. So, first I will go to analyze. So, you are doing the during the stepwise also you are doing something similar. So, reset. So, first is I am taking the y as my dependent variable, which is my literacy, female literacy. Now, there in during, if you remember, in the stepwise what we were doing, we were taking all the 3 variables x1, x2, x3 and then we were giving it an approach ki whether we want to take it enter, that means all at one time, or stepwise, that means that the computer decides which is the highest best predictor and then the next predictor, or we use the backward forward or any of these methods. But here we are not doing that. What we are doing is we will use a block method. So, first I am taking the independent variable x1 here and then I am saying next, then I am going to the x2 and x3 and I am considering this to be the next block. So, there are how many blocks now? 2 blocks, although there are 3 variables, there are 2 blocks. Okay. So, you could have made 3 blocks also if your logic permits that, but then if you have made 3 blocks, then the point is what is the order that you have to decide. Okay. Now, going to statistics, I want the R square change because this is what will tell me my contribution, the descriptives, the partial correlation and the collinearity diagnostics to ensure that there is no multicollinearity problem. Now, look at it. Now, if you look at this, this is the descriptive statistics which you I think I am sure you can understand and you can utilize. Now, this is the correlation, right. Now, let us see the model summary. Now, yes, this is of my greatest importance. Now, when I am using the x1, so there are 2 models, 2 blocks, 2 models. The first model, for the first part of the equation, when I used x1 only, my R was 0.711 and I am sure this R you understand, this is the multi correlation, right, and R square is the square of it 0.505. Now, adjusted R square is similar to that, right, 0.504. Now, this is significant? Yes, it is significant. Now, second, when we entered the second block, that is x2 and x3 together, so the new correlation is 0.787 and R square is now 61.9 or 0.619, and if you look at the significance, it is also significant. That means both are significant, both are explaining, right. There is no effect, that null hypothesis that it has no effect is being rejected, right. Now, if I go back, now let us go back to my PPT. So, now this is my model summary, right. So, check the R square and you see that it explained how much, 50%, 50% of the variance, right. After block 2 has been included, the model explains how much, 61.6 adjusted R square I am taking, right, and right. So, the additional 11.4% or 11%, I am just for easy I have written 11%. Variance in the dependent variable is explained by this 2 new variables, right. This is significant contribution as you can see from here, right. Now, what does the ANOVA table tell us? The ANOVA table indicates that the model as a whole is significant. Now, you see F 385. So, what it is saying, 3 and 385. So, when you are having numerator and denominator and your value is how much, 208.674 and it is significant. Okay. Now, interpretation how it is given or how you should write, all the variables make a significant contribution, yes, because it is all significant, right. So, x1, x2, x3 all are significant. The best predictor is female literacy, which is the y, is which one? Now, x3. Now, let us see what is x3 doing. Now, x3 the beta value is how much? 0.352, so highest, right. And it is not because you have put it in this order, sometimes it could have been different also, the orders might have changed, it is because it is contributing. And what is this? This is my per capita income of the parents, let us say, of the family, right. This was x1 was the population, right, growth, and this was the GDP. So, if you look at it, followed by x2, so first per capita, then GDP, and then finally which one? The population growth. These 3 in this order they are contributing. Okay. Now, how do you write? Hierarchical multiple regression was performed to investigate the effect of annual population increase, a greater gross domestic product and a higher per capita income to predict the levels of female literacy after controlling for x2 and x3, right. So, if you do not write this also no issues, right, but you understand for understanding. So, in the first step predator was entered, one predator was entered. If in your case, suppose in another case you are doing and there are 2 predators, so we will say 2 predators were entered, right. Annual population increase x1, this was significant at C f1 387, right, and this is significant at 005 and explained 50% of the variance. This is how you should write. This factor made a significant unique contribution to the model. After entry of x2 and x3, the total variance explained is now 61% and this is how you should write, and the explained additional explanation was 11%, right. So, in the final adjusted model, all the predators were statistically significant, with x3 recording a higher beta value this much than x2 and this. So, this is how you should write the output of the hierarchical multiple regression, right. So, here this is what was of my interest to tell you how to understand hierarchical multiple regression, that it follows a logic, and then how to do it and how to write the interpretation, most important. Okay. I think you must be clear by now. If you will have doubts, then you may ask me in the during the question answer forum. Now, I will continue to a special case of regression. This special case of regression is called dummy variable regression. Now, what is this dummy variable regression? Let me show you. If you remember, initially we said that all independent and dependent variables in the regression model should be continuous, right. But sometimes it happens in life that you need to include a categorical variable or a qualitative variable into the regression equation, right. So, how do we deal with this case now? So, whether someone has a college degree or not may influence the salary the person gets, possible, right. So, having a degree or not having a degree, let us say 1 0. Now, the presence or absence or 1 0 may influence the salary he gets. The location of a house can change its value. I think you all will agree, if the house is in an urban place, the cost will be more, the price will be more than in the rural. The season can be used when predicting the number of flights arriving in India or anywhere. Similarly, whether a company is public or private may have a role in explaining its exports level, possible, right. So, these are some of the variables which are all categorical, but they do have an impact during the regression equation. How do we include these variables into the study and explain them, right? Let us see. So, a dummy variable is a easy way of incorporating a qualitative variable or a categorical variable into a regression model by representing them with special types of variables called dummy variables. So, it is a dummy variable case, right. That a dummy variable is a variable that indicates only, very simple, you see, the presence or absence, it is whether it is present or absent of some characteristics or attribute. The dummy variable assumes the value of 1 if it is present, 0 if it is absent, that is all. Dummy variables are also called indicator variables, categorical variables or binary variables because of their property. Let us say we want to predict the salary of a customer service agent. We think that the years of experience is one of the variables that can have an impact, right. We would also like to include whether the person is a college graduate or not. So, what are the variables? One, that how many years of experience. So, this is a continuous data, right. But the second one, whether he is a college graduate or not, that may also influence his educational level. Now, this is a categorical variable, right. So, now I have one continuous, one categorical. This I could have done, the dependent variable is salary. So, if I would have taken only this one, it would have been a simple regression. But if I am taking 2, then it is a case of a multiple regression, and the problem here is, but this is the second one is a categorical thing. So, consider the respondent's sex. The variable sex has 2 categories, one for male and 2 for female similarly. What we do is to create 2 dummy variables, one for males and the other for females. So, how do we do it? 1 if male, 0 if female, and 1 if female, suppose somebody is a female, then 1 if female, 0 if male. So, it is like absent present. Okay. Remember, when you have k categories, suppose in the case of gender, how many? Male and female, 2 categories. So, you will use k minus 1 dummy variable. So, how many here? Now, only 1, 2 minus 1 is equal to 1, right. Suppose there would have been 3 categories, then how many you will have groups? Now, 2, 3 minus 1 is equal to 2, right. The category that you omit, the third becomes your comparison group, right. So, this is what you compare it with. So, So, we are going to enter the, let us say, the sex male into the analysis and omit sex female. That means that females will be the comparison group. I will show you with an example. A dummy variable can only take two values 0 or 1, right. So, for continuous variable coefficient, B1 is interpreted the slope, the change in the predicted value of annual salary y with 1 unit change in years of experience, true, right. So, how much 1 unit change with a 1 unit change, how much the annual salary is changing. For dummy variable coefficient B2, which is the categorical second case, the change in the predicted value of the annual salary when the person is a college graduate versus when he or she is not, now not with a 1 unit change in x2. How this is 1 unit change? Because there is only 1 and 0, two values. So, either it is a 1 or it is a 0, right. So, let us, so what it says is, if you draw this annual salary and years of experience, for example, with college degree, without college degree, without college degree and with college degree, the dummy variable affects the intercept, you see the intercept is affected, but not the slope, the angle is the same. So, the rate of change does not change, right, but the intercept changes. Okay. So, let us take this regression equation, y is equal to 25 is a given years of experience, right, just sorry, this is the intercept, sorry, is just hypothetically a y and is equal to y estimate is equal to a plus b1 x1 plus b2 x2. Okay. So, a is this one, b1 is my slope, right, for the first one, first independent variable, and b2 is my second, right. So, x2 is my categorical variable, x1 is my, in this case, my experience. So, experience plus college graduate or not. Okay. Assume that a person has 5 years of experience. So, this is 5. Okay. What would be salary if he is not a college graduate? If he is not a college graduate, so just, or what would his salary be if he is a college graduate? Now, you have to understand. So, if you use this, if it is 1 or 0 depending, right. So, you can always compare whether if it is 0, then, but you should know what is 1 and what is 0, 1 is for male, 0 is for female, or whatever it is, right. So, let us see this. So, if he is not a college graduate, so what it is becoming 225 plus 2.5 into 5 plus not a college graduate, so 0. So, my salary is 37.5, but if it is a college graduate 45.5. So, this is the difference. Okay. Now, multi category, when we have more than 2 levels, right. So, let us say for season, we cannot assign numbers 1, 2, 3, 4 because a dummy variable can only take 2 values 0 and 1. So, instead we use multiple dummy variables to code it, right. So, again the levels will be d minus 1. So, k minus 1 or d minus 1, however you may show, right. And the base condition, take one level to be the base condition where all the dummy variables are 0. Okay. Now, let us see this. To code seasons, we need how many dummy variables? There are how many seasons in a year? 4. So, 4 minus 1, 3 dummy variables you require, x1, x2, x3. So, let us say winter. So, 0, it is not a winter, x2, it is not even this one, right. So, this is a base case. Spring, if it is x1, let us say x1 is 1 and this is 0, right. So, the third one also will be, fourth one will also be 0. Summer 0 1 0 0 0 1. So, if you see it is either only one of it or it is not there, right. So, winter is 0 0 0, right, it is saying in the case of winter 0 0 0. So, we designate, as you can see, x1 to represent spring, x2 to represent summer, x3 fall, right. So, these 3 it has been taken, right. Only one of the dummy variables can be at one at a time. So, winter, summer and fall we have taken, winter, spring, summer and fall, and this is our comparison group, right. So, when it is a case of winter, all are 0 obviously, when it is spring, it is 1 0 0, right. So, 1 0 0, when it is summer you just see 0 1 0. So, you can do that, right. Hence, we need only 3 dummy variables to capture our information. We do not want to create a fourth dummy variable because it will be redundant, unnecessary, because the category is already represented by the other 3 dummy variables. When each of the dummy variable is 0, it must be the fourth one, which is winter in this case, right. If it is all 0 0 0 0, then it is a case of a winter, right. If it is 1 for it is x1, this is spring, right, x1 is spring. So, if it is 1, then it cannot be winter or summer or fall, same thing, right. The category is one category is excluded or called the reference category, and the beta coefficient for each dummy variable is compared against it. So, that means what? You have one comparison group or reference category which is comparison or reference, right, and every other variable is compared against this reference category. Okay. Let us see that. Now, how do you do it? Simple linear regression. So, we will begin this with the coding of male and female gender, right. So, how do you code? Why we must do? I think I have explained, so I am not getting into it. So, steps to be followed. To begin, select transform and recode into different variables, right. Let me show you instead of telling you. So, let us go to the dummy variable, the simple one. So, this is the one which I had already done. I may delete it also, I can delete it, or if you can see, I can again do it in a different name, maybe this, let it this be analyze, transform. Now, go to this record into different variables. Now, what do we want to change? Now, gender I want to change. Now, what do you want to name it? Now, you have to give a label. Okay. So, the label is, let us say I am giving is this time gender, okay, some just to differentiate 2, okay, and you just label it as, let us say gender G, okay. So, change. Now, go to the old and new values and now put in the value. For example, in your case, in this case, for example, 1 is, let us say male and 2 is female, let us say. So, value 1, what is the value? 1, and what is the new value? Now, the new value is 0, right, add, and all other values will be how much? Now, 1. So, you add this. So, 1 is 0 and others are all 1, continue, right, and ok. Now, if you see, we have created a similar same thing, this is same thing, earlier I had done it earlier and I wanted to show you how to do it. Now, we have created a variable, right. Now, let us go back to the steps. So, right, so the variable is created and then you can use it for regression. Suppose, let us go back. Now, I want to do a regression to study the effect of gender on customer attitude. Now, what I am doing is go to regression linear. So, my customer attitude is my dependent variable. This should have been in scale, but do not worry, you can change that. And gender 2, now this is, imagine this is the new one which I have built, is my independent variable. Now, what I am doing is I am trying to measure it. So, I do not want anything else, I just want to run it and see the effect. So, how much impact is gender making on the customer attitude or the product on the the attitude towards the product? Now, R square is 82%. So, gender explains 82% of the study, okay, and it is significant, right. So, that means what? In this case we can say gender is a very important variable which affects the consumer attitude or the customer attitude, okay. Now, let us go back. Now, this was, you see, this is how it comes, right. So, so the coefficient I have written this all for you. So, the output we can calculate the mean customer attitude towards advertisement for men and women, maybe it was customer attitude towards advertisements, right. So, y is equal to a plus bx, where y is equal to is the dependent variable, x is our independent variable which is gender, okay. So, now if you look, let us go back to the same data set. Now, this is my a, right. So, we know y is equal to a plus b of x, right. So, y is equal to a is my 3.5 plus b is how much? Now, b is gender, right. So, if you see 2.5, right, 2.5 into 2.5 into gender, whether it is a male or a female, we have said, right. So, if you see what we have done, male was 1, female was 0, female was 1. So, if you do that, so the customer attitude for females is coming 6, for males it is coming 3.5. So, on an average, female respondents reported a customer attitude score that is 2.5 points higher than the male respondents. This is how you interpret, okay. And the R square was 82.2%, which is explained by the gender. This is also you should mention, right. So, this is I will show you a new example now. Now, this is a one categorical independent variable with several categories. Okay. Suppose this is interesting, you want to see how the customer attitude score of the respondents towards advertisement is related to their ethnic group. So, now we have taken various ethnic groups, for example, one Kashmiris. In India these are different states and people from these states are called like this. West Bengal, Bengalis, 2, Punjab, Punjabis, Tamil Nadu, Tamil, and rest are others. Okay. However, because linear regression assumes all independent variables are numerical, so we have to now convert it into a, since these are all categorical variables, we have to do a dummy variable, right. So, what we will do, you see here, each dummy variable represents one category of the explanatory variable and is coded with 1, we have done earlier also, if the case falls in that category, and with 0 if not. Okay. For example, if the dummy variable for Bengalis ethnicity, all cases in which the young person's ethnicity is Bengali will be coded as 1 and others as 0. Similarly, for Kashmiri, Tamil and others. Okay. So, how do you do? First recode into different variables, same thing. Now, move to the numerical variable output and here type in the name and label of the first dummy variable. Suppose 1 is Kashmiri, in the ethnic group 2 variable clues we can start by creating the Kashmiri. Suppose in our case in the original data which I will show you now, let us say I have brought the data set. Now, let us go to the variable view. Now, you see this, I already know that 1 is Kashmiri, 2 is Bengali, 3 is Punjabi, is a coding, just a coding, right, 4 is Tamil, 5 is other. Okay. So, I know it. Okay. So, now how do I create my dummy variables? So, let us do it, let us transform. Now, we go to the recode into different variables. So, we want ethnicity. So, I have already taken. So, let us reset it, okay, ethnicity. The first one I am doing it for, let us go to the key. So, Kashmir, right, Kashmir, and I want to label it as only K, it is for just change, easy, right. Old and new values. What was the old value for Kashmir? I have shown you earlier, it was 1. So, and the new value is also 1. So, I am adding it. Now, you see coming to here, all other values I will put it as 0, right. So, all other values are 0. Now, add, continue, and you just give it OK. So, if you go to the file, you see this file, not this file, the other file, right, this. So, the Kashmir one label has been created for Kashmir. Similarly, again we will do it for Bengalis, correct. So, here I will change it to Bengal, and I will mark it as B. Okay. So, Bengal was 2, right. So, here I am changing old and new values. So, my this is old value is 2 and new value is 1, add. Now, let us do it for the others, right, transform, recode. So, now we have taken already Bengal. So, Bengal I have given B, right, and then I will go to the values. So, let us say if you have, I will just show you again, I will show you. So, the old value for Bengal was what, 2, right. So, old value for Bengal was 2. So, but now the present value will be, because dummy it is 1, add. So, all other values will be marked as 0, right, 0. So, continue, right, and OK. Now, let us go back to the model. So, you have created one file for Bengal, right. Now, again go for the third was, if I remember, let us check what was the third was Punjabi, then Tamil, then other. Okay. So, let us go to the third one. So, transform, right. So, this one we will change it now. So, this is Punjabi, let us say Punjab, right, Punjab, and this is, we are giving it a big P. Okay. Change. So, it has changed here. Now, old value for Punjab was 3, okay, and you just have to remove these two, okay, earlier data. So, So, again let us do it 3. So, Punjabi was 3, now it is 1. All other values will be marked as, so value is 3, Punjab was 3, now we are marking it 1, we need to add it and then go to all other values and mark it 0, right. So, again add it. So, now continue, right. Okay. So, you will see that a new variable has been created. Similarly, we will create it for Tamil and others also. So, let us make it fast, different variables. So, ethnicity is Tamil, Tamil, and this is T, change old and new values. First remove these things, otherwise they will confuse you. So, this is 4, right, 4. So, and this is now it is 1, add it, all other values kindly make it 0, add it again, continue, okay, right. So, let us see. So, again a Tamil has been created and finally, we need to go for the last, which is the for others, right. So, this is others, other, and this is let us say O, change old and new values. So, this is 5, right, this is 5. So, 5 here, make it 5 and here it is 1, right, add, and all other values you make it 0, right, add, okay, okay. So, now you see you got 5 factors, right, the dummy 5 dummy variables have been created, but when there are 5 we said we always need 4, right, k minus 1. So, we need 5 minus 1 to see the effect, okay, and the last one will be the reference or the comparison group. Now, I want to see the effect of this on the customer attitude on the by the ethnicity, right. So, let us go to regression linear. So, my customer attitude is my dependent variable, and now what I am doing is I am taking Kashmir as my reference group. So, I am leaving it and Punjabi, Tamil, others as my independent variables. Now, statistics, I just want to see the descriptives, the R square, that is all, even that much, that also I do not require, I just need to check the model. Now, you see the mean and standard deviation has been given to you, right. Now, if you look at the model, so for the this is the correlation, right, and go down the model summary. So, this model is explaining almost 99.2%, that means ethnicity affects the effect of ethnicity on consumer attitude of advertisements is 99% in this case, it is highly significant. And look at the coefficients. So, if you look at the coefficients, what it will be now, B is the beta, the constant intercept is this much and it is all significant. So, let me, and the slopes are also given to you, right. So, let us go to the, here I have used the same data and I have explained, right. So, now after doing this, in this example we have used Kashmiris as the baseline category. So, that is why we did not take it inside. As the Kashmiris variable is now a baseline, we do not have to include in the linear regression model, right. We will however need to include all the other dummy variables for ethnicity, right, like for example, Punjabi, Tamil, others, we have done it. And then we have taken this output. So, this output you remember R square was 99.2, adjusted R square is this much, it is significant, and this is what is of greater importance to us. Now, if you look at it, so in this case Kashmiris is our baseline and therefore, the constant coefficient of 0.9687 this one, right, represents the predicted consumer attitude score of a respondent in this category. That means, this is the intercept actually when the x is not there, no x is there, the independent predictors are not there, still it is 9.687. Remember that the dummy variables are coded as Bengalis 1, Punjabis 1, Tamil 1, others 1. This means that we will enter in 1 as the value for x, right. So, this is how it looks like. So, 9.687 A plus B x, okay. So, x is for example, for the 1, now for the first case Bengalis case. So, what is the comparison group? Kashmiris. So, Bengalis are being compared to Kashmiris, Punjabis are being compared to Kashmiris, Tamils are being compared to Kashmiris, others are being compared to Kashmiris. So, if you look at the first one, minus 2.5, minus 4.5, minus 6.5 Bengali, minus 2.5 Punjabi, minus 4.5, it goes on, right. So, this is when you multiply, this is what the score, total score you are getting individually for Bengalis separately. So, it means that if let us say on an average Bengalis respondents report a consumer attitude score that is 2.5 times lower, points lower than the Kashmiri respondents, right. So, in this case our Kashmiri respondent is 0, right. So, that means what, it is only 9.687. So, 9.687 minus 7.187. So, 0.05972, right. So, this is what. So, this is 5.187. So, all the time reference category is 0. So, that is why we have when we compare we can say that this is 4.5 times, this is 6.5 times and this is 8.5 times. So, basically now it has helped you to understand the effect of ethnicity, a categorical variable, on the dependent variable consumer attitude towards the advertisement, and you see how nicely it has explained you and how well you can maybe use it in the research work. So, remember we can use this R-square statistic to gauge how much variation in the dependent variable is explained by the independent variable, right. R square is 99.2, that means which is being explained by ethnicity. How do you report? A simple linear regression was calculated to predict consumer attitude towards advertisement based on ethnicity, and the regression equation was found at F435 was this much and significant with an R square of this much. So, this is what you write, but I will do one more thing, I will show you how to do when you have a dummy variable and also a let us say a continuous variable. Now, in this case you see I have a continuous variable price, the price let us say of the product and the ethnicity of the people. Now, again I will do this, and what I will do is I will take linear and I will take this price also into here, price actually let me change it, the variable view. So, price is my scale, it is not a others are nominal, that is fine, right. So, now let us do this. So, analyze, regression, linear, reset, okay. So, dependent variable is attitude, price is my independent variable, and here I am taking 4 of it, right. So, and let us run this model, right. So, okay. So, if you look at it, nothing much has changed, okay. So, only price has been introduced into this model. So, price has got a beta, the B, the beta, the B slope, the B1 of price is 0.032. That means what? A 1 unit in price of the product will decrease the consumer attitude towards the product in a negative way, right. This is because it is a minus 0.032 and other things remaining the same. Then, and whether it is significant, whether price has got a significant effect? Well, no, it is not a significant effect. So, we cannot say that price has has any effect or not, we cannot say that. So, we will conclude that price has no effect on the consumer attitude, but had it been significant, then you could have used this value into the regression equation and taken all other dummy variables value into the as the categorical variable in second equation into the second variable and measure the y, and you could see the change when you have introduced now a variable. Now, it will look like something like this. For example, here let us go. So, if y is equal to a plus b1 x1, which is this time might be my my price, okay, plus b2 x2 b3 x3 x3 plus b4 x4. So, x1 x2 was what? Now the x2 is my, let us say, the Bengali, Punjabi, right, the Tamil, and plus b4 b5 x5, which is my others. So, we can, this is a recent equation, the latest equation we will get. So, by using this method, you have understood, by using dummy variable you can do so many wonderful researches and you can interpret them so nicely, and you can you can report it and maybe it will help you in publishing your paper. So, it is not only the dummy variable, but also dummy variable with the continuous variable together you have taken into the equation and interpreted the result. Okay. Well, I think it is clear to you, and you have understood what does dummy variable mean. It is a very special case of regression, very interesting, very useful, and you can use it for your benefit, and you can write several research papers on that. Well, thank you so much. Have a nice day.